I hope you're able to see my screen, right? Okay. So first, on ANN, what is a biological neuron? All those things have you learnt it? That is, what is a biological neuron? How it looks? Anyway, I'll start with that only. So let us see how a biological neuron looks. So here you can see these are all dendrites. Okay, these are all dendrites, and this is the axon terminal. Okay, and this is the neuron body, that is called the cell. Here the cell body, and this is the myelin sheet. This is the myelin sheet, which will be connecting the dendrite and the axon. So this is how our biological neuron looks. Are you getting it? So you will have dendrites where you will be receiving inputs from the previous neuron. So when you are talking about biological neural system, what is it comprised of? It is comprised of neurons, mainly the sensory organs, which is also a neuron. That is, it starts from the neuron and managed by the brain, right? So if you touch any hard substance, what will happen? The information is traversed from the place where you have touched to the brain through the neurons only. Okay, so how it is transferred? It is transferred like electrical signals. Okay, so here dendrite, the first neurons dendrite will receive the electrical signal, and it will transfer to the next neuron through the axon terminal. Okay, so that is why it is told as, here you can see x1, x2, xn, all these are inputs, and y1, y2, ym, all these are outputs, right? So when you will be receiving a electrical signal which is to tell that it is a hard surface or anything like that. Here in our implementation, what we are doing, we are going to find out which sign it is, right? So how will you get to know? Eyes will, when you see through the eyes, what will happen? You will get to know whether which sign it is, right? That is a sensory organ which will send signal to the brain in order to find out whether whatever image that has been received belongs to which particular sign. So like that, sensory organs many are there. Taste, what will happen? If it is salty, if it is sour, if it is bitter, everything goes to the brain, right? So that signal is actually traversed from the neurons to the next neuron, and it continues until it reaches brain. Okay, so and then brain decides. If you have touched a hard surface, brain decides to take your hands off, right, from that surface, right? So that is called the biological neural network. So biological neural network means which is in the human body. But when it comes to which that is artificial neural network, ANN is just you are replicating that as a mathematical model, replicating the whole what is a neuron into a mathematical model is called the artificial neural network. So let us see this image. You can see this image. I hope you are able to see the images what I'm showing. uh, I think this image exactly tells how the mathematical model of a node or the neuron. This is called the node. They will tell it as node here, and how the neuron is converted into a node here. Okay, so here we can get that dendrites inputs are given, right? Dendrites inputs are given, and then there is some calculation inside this, or some chemical reaction inside this, which will be converted into electrical signal in the axon. and that will be given to the next dendrite. Same way here you have got inputs, right? These are the inputs. For example, that is in order to find whether a particular thing, whether it is a fire or not. For example, I'm just asking you, I'm just telling you, one of the sensory organ, that is eyes, will see the flames, right? That is fire's flame is there, no? That you will be able to see. And then another sensory organ feel the heat, maybe that is skin is another one. And the third sensory organ, maybe the nose, it may sense the smoke, right? So all these are having some weightage value. See, if you see that directly through the eyes, then it will have the highest weightage value. That is, that we know that it is a fire, right? So just by seeing we will be able to find out that it is a fire. So it will have a weightage value for each input. Okay, so that is called weight. W value will be there for every connection from the input to the node. We'll be having W values. Okay, so input into W, input 2 into W2, input 3 into W3, all these product you will be summing it. That is what is called summation. The summation, whatever you are seeing here, it is the summation. Okay, then it will be given to the activation function. So I told you about some chemical reaction which converts into electrical signal here, right? So that is called F. It is that is if you mathematically equate it, it will be the function. Okay, so it will be the activation function. The summation value you will be giving to the activation function. And summation value, it is also supported by a bias value in order to it is called a additive adjustment. Here it is, weight value is multiplicative adjustment. That is, you actually want to bring this particular node to learn that whatever is given is fire. See, initially when you are kid, right, you would have touched a hot surface without knowing that it is hot. But once your brain got trained, then you will not touch it, right? So that training is there, no? That needs output also. So whenever you are training, what should be there? Input and output both must be there. But while testing, only input you have to do. That is, while you were kid, you had touched it and then found out it is hot, and maybe by seeing it, you would have found that it is a hot surface or whatever. That input and output both were there, right? But once you are trained, only input is enough. Automatically output you will be finding it out. So that is the training method. Training needs input and output both, and testing doesn't need that. So actually, while you are applying a project or any product or anything like that, testing alone will be happening online, but training you would have done it offline. That is, in your system you would have continuously trained it, and the model which has been trained, right, that will be given to test. That is, testing is nothing but live. It will be live in the product. Okay, so this is how we'll be training. This is how neuron is actually, the biological neuron is replicated as a mathematical neuron here. Okay, so let us see how that a node in a ANN looks. Let us see that. Node in the ANN. Okay, let us see this. This is a node in the ANN. Right, what I told you, there will be weight value. See, if you have if you want to find fire, no weight for the eye, if it is the eye's input, then it will be having a higher what is that, higher weightage. So mathematically, when you are telling, it will be some numerical values will be given here, and that will be multiplied with a weight value, and it will be the multiplied x1 into w1j it is summation, right? So plus x2 into w2j plus x3 into w3j plus n into wnj, like that you will be having, and it will be connected to the, again this is the transfer function I was telling you, that is the activation function. You will be summating it and then you will be giving it to the activation function. Maybe it is sigmoidal or exponential. There are multiple activation function you will be needing, because in order to map the input and output you need to have that activation function, then only that non-linear mapping can happen. Okay, so the net input net j is nothing but the summation output is called the net j. That will be given to the activation function. That output, this output will become x1 for the next node. Okay, for the next node, this output will be the x1 for the next node. Like this, it will be connected continuously connected. So, for example, how it will be connected, we'll see that network. See here, you can see that whole thing what I taught you, this whole thing will be in one node. In this node only it will be there. In this node only this whole thing will be there. Summation, giving to the activation function, finding the output. Like that you will have, this is called the input nodes, this is the hidden layer, and this is the output layer. If you have got two decisions to be made, then multiple outputs will be there, right? So this is how we'll be implementing it. Once again, one second. Okay, sorry. So here the thing is, you'll be having similarly like this node only, multiple nodes will be there in order to find out any classification. Here what we'll be having is we'll be finding out which through regression we'll be finding out which particular sign language it is being given as an input. So here when we are using image processing algorithm, here the whole image will be given. When it comes to deep learning method, whole image, the pixels, all the pixels will be given as an input. And when it comes to deep learning, you will have multiple connections, even there will be connection from the output layer to the backside also. So that is called the recurrent neural network. So usually this particular setup is called the feed forward neural network. All the output will be given only to the next neurons only to the next neurons, that is called feed forward. When it comes to connection between the neuron, the output neuron back to the input neuron, then it is called recurrent neural network. So like that, the connection, according to the connection that the nodes are connected, this neural network is actually it is classified into multiple types. So here this particular thing is called feed forward neural network. Okay, so how the training happens in the neural network, we'll see that. There are many methods, that is regression in neural network happens, that is using gradient descent method, and then Newton's method. There are multiple methods that we'll be having, but we'll just have a look at how simple training happens in a neural network. Okay, we'll just see this in a simple way. Whether it is in supervised or unsupervised method, it is a supervised method because we are checking whether the training has happened or not. So here no images are there. We will go to some other. Okay, let us see in this. Okay, towards data science. So Vitaly Bushev has written something on this. We'll see that. See this, you got it right. This is a single perceptron. That is only one node. If it is there, this is how it looks. It is a single perceptron model. So like that, this I think you know it, right? W1 into x1 plus w2 into x2. This is one of the method. Okay, this is one of the method how the f of x1 x2 is done. And rectified linear unit also is there, where you'll be finding the max of the inputs x comma 0. You'll be finding the max of it. If it is negative, then it will be made positive. Okay, and then another way also we can do, that is it is another way of finding the final formula of neuron is max of 0 w1 x1 w2 x2. So this is one way of applying the nonlinear function. So there are multiple things, but usual thing is this one, f of x1 x2 is equal to w1 x1 plus w2 x2. This is the usual way how we'll be doing. And what is the variable here? W1 w2, that is the variable. We can change it, right? See, if you want to train a multiplication table, okay, for example 5 into 2 is equal to 10. Okay, so that without the mathematical thing, it has to find out. ANN will do that. Once it has learned, then it will automatically do it, right? So what I'll do is 5 into some weight value, that is W1. If I'm taking 5 into W1 must be 10. Okay, so 5 into 2 is 10, but first I'll be giving it as 1. Okay, 5 into 1 is 5, and whether it has reached 10, no. So 10 minus 5 is a error. So in order to reduce that error, W will be updated again. I hope you are getting it right. W will be updated again in order to reach 10. Okay, so again what we'll do, 5 into 1.6 maybe it will come. Then again we'll check whether it has reached 10 or not. Like that it continues. This W1 and W2 are weight values, and bias also is there, which is additive adjustment. This is a multiplicative adjustment. You are adjusting it in order to multiply with the input in order to get the actual output, right? So like that you will be having the same way. You will be having the bias value also, where it will be added actually. Okay, so here it is neural network, simple neural network. X1 X2 is the input, and this N3's output will be the Y value, which will be having the output. Okay, so yeah, here you can see sigmoidal of the input value that you are found. Okay, so all the whole w1 x1 plus w2 x2, the whole thing is there, no? This whole thing f of x1 or x2 will be given as a input to the sigmoid. Okay, sigmoidal function, how it will look: 1 by 1 plus e power minus x, like that it will be looking. In that, x value is there, right? That will be this whole value. What is that? F1 x1 plus f, that is w1 x1 plus w2 x2. The whole value will be put it in the x value, 1 by 1 plus e power minus x. If we are using that, in that x you will be making the whole value to be placed. Okay, and then in order to stop the iteration, where it has to stop, you are updating the w value every time. Okay, but you have to stop the iteration, right? So this is called the mean square error. Okay, you have to stop the iteration at a particular point. M is the total number of values, and then this wi is there, right? Wi is the actual output that you are getting, or wi cap will be the actual output you are getting, and yi is the output that we need to train. Okay, so if you subtract and square it, it is error square. So, and then if you divide by m, mean square error. Okay, so this mean square error, you will be for stopping the neural network training, this will be the criteria. You have to reduce the mean square error to a very less value. If it reaches that lowest value, until that you have to be continuously training it. Okay, so this is how the neural network training will happen. So in when you are yeah, here you can see the weight value is updated every time. Okay, this is the gradient descent method. Del of L divided by del Wj. The error is propagated, and you are giving it to, see, the output nodes error will be propagated to the hidden layer error, and hidden layers error will be propagated to the input layer error. Like that, the propagation of W will help you to train the neural network to get the actual output, right? I hope you got that, how it works. Yes, Sahana, any one of you, have you got that, how the ANN gets trained? Yeah, so same way we'll be applying for training the all our sign language is there, right? That will be made to train in our implementation using the deep learning method. It is similar, only thing is the structure of the ANN is there, right? And then there will be there will be layers like LSTM and all in deep learning method that will be dealing in the coming classes. So that using LSTM and ANN, if you combine, it will become a deep learning network. The convolution neural network and recurrent neural network, all these um, comprises the what is that, deep learning method. So that is how the deep learning method is implemented. uh, yeah, that's all about today's class. The thing is, when it the sign language, when you are training using the deep learning method. And then the output will be got, we'll be generating a what is that, database in which the sign languages are taken, and also the sign language, which sign language it is, according to that numerical output you will be setting. For example, if it is good morning, for good morning 1 will be the output, or like that. For good afternoon, or multiple sign languages are there. For that you will be having a particular numerical value that you will be training using the deep learning method, and this whatever input is there, that will be trained on the neural network, and that trained model is used for testing it on the Raspberry Pi. Okay, so this is how we are implementing it. Okay, so have you got any doubts in this CNN implementation? Sahana, I'm not hearing your voice actually. Yeah, tell me, Sahana. Okay. Next class we'll be having the coding, Python coding, for how the sign language is trained on the deep learning thing. Okay. So that next class you can book in the online itself. Okay, you can just check that and you can book it. Maybe I'll just check the calendar whether it is there. Yeah, I think tomorrow you may get, you try to connect it, that is book it. Yeah. ಹಲೋ ಸರ್, ನಮಸ್ತೆ ಸರ್, ಹೇಳಿ. ಇಲ್ಲ ಸರ್, ಇವಾಗ ತಾನೇ ಬಂತು ಕಾಲು ನನಗೆ. ಹಾಂ, ಆಗಿರುತ್ತೆ ಅನಿಸುತ್ತೆ ಸರ್. ನಾನು ಚೆಕ್ ಮಾಡ್ಬಿಟ್ಟು ಹೇಳಲ್ಲ ನಿಮಗೆ, ಇವ್ರ ಹತ್ರ, ದಾಮೋದರ್ ಹತ್ರ. ಅದು ಇಲ್ಲ ಸರ್, ಇಲ್ಲ, ಅದು ಆ್ಯಕ್ಚುಲಿ ಈ ಕರೆಕ್ಷನ್ ಬಂದಮೇಲೆ ಆ ಕರೆಕ್ಷನ್ ಔಟ್ಪುಟ್ನ ಹಾಗೆ ಪಿ ಪಿ ಟಿಯಲ್ಲಿ ಹಾಕೋ ಥರ ಪ್ಲ್ಯಾನ್ ಮಾಡ್ಕೊಂಡಿದ್ದೆ. ಅದನ್ನೇ ನಾನು ಹೇಳ್ತೀನಿ ಸರ್ ನಿಮಗೆ. ಓಕೆ. ಹೌದು ಸರ್, ಹೌದು. 14th ಸರ್, ಒಂದು ನಿಮಿಷ, ಏನೇನು ಕ್ಲಾಸಸ್ ಇದೆ ಅಂತ ನೋಡ್ಕೋತೀನಿ. ಮಧ್ಯಾಹ್ನ ತನಕ ಇದೆ ಸರ್ ಕ್ಲಾಸಸ್ಸು. ಸರ್, ನಾಳೆ ಬರೋಕ್ಕಾಗುತ್ತಾ? ನಾಳೆ ಅಂದರೆ 10 ಗಂಟೆ ಮತ್ತು 2 ಗಂಟೆಗಿದೆ ಕ್ಲಾಸು. ಸರ್, ನಾನು ಒಂದು ಸ್ವಲ್ಪ ಬಿಟ್ಟು ನಾನು ತಿರ್ಗಾ ಕಾಲ್ ಮಾಡಲ ನಿಮಗೆ? ಓಕೆ, ಇಲ್ಲಾಂದರೆ ನಾನು ವಾಟ್ಸಪ್ಪಲ್ಲಿ ಮೆಸೇಜ್ ಮಾಡ್ತೀನಿ ನಿಮಗೆ. ಓಕೆ, ನಾನು ಅಪ್ಡೇಟ್ ಮಾಡ್ತೀನಿ ಸರ್. ಇವಾಗ ಕೇಳ್ಬಿಟ್ಟು ತಕ್ಷಣ ಅಪ್ಡೇಟ್ ಮಾಡ್ತೀನಿ ನಿಮಗೆ. ಓಕೆ ಸರ್. ಹಾಂ, ಆಯಿತು ಸರ್, ಆಯಿತು. ನಾನು ಚೆಕ್ ಮಾಡಿಬಿಟ್ಟು ಹೇಳ್ತೀನಿ. ನಾನು ಇನ್ನೊಂದು ಕ್ಲಾಸಲ್ಲಿದ್ದೆ, ಮುಗಿಸ್ಬಿಟ್ಟು ನಾನು ನಿಮಗೆ ಕೇಳ್ಬಿಟ್ಟು ಇದು ಮಾಡಿಬಿಡ್ತೀನಿ ನಿಮಗೆ ಇಮಿಡಿಯೇಟ್. ಆಯಿತು ಸರ್, ಆಯಿತು. ಓಕೆ ಸರ್, ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.